This is the second video that we are recording on the SACRO ML data repository. If you don't know what SACRO ML, the explanation is here: semi-automated checking of research outputs in trusted research environment. In this video, we're going to be running AI attacks. We're going to train the AI model and we're going to attack the AI model. So within those two sections, which I'm going to show you in this video, with few lines of code, you would be able to perform the same exercises at home. My name is Peter. Next to me, I have Kai, who is helping me with technical support in case something goes wrong with the code. We're going to be using the Virtual Studio coding environment for this, and we have all the text written here, so we're going to be running the codes. Just for info, you have to watch the first video where we showed you how to install the SACRO ML, how to clone the code. So this is git clone. It's only like a 5-minute short video, and in that video I gave you instructions on how to do it for Windows or how to do it for Mac, because those are two separate command lines. As you can see, the command for Windows are not going to work on a Mac. So that is the command for Windows, and the equivalent for Mac is going to be this one. So you can follow those steps and perform the first part. Now we're going to do the second part, where we're going to run the attacks. First, we have to install the environment that we cloned over here, and that's a few simple commands. Let me show you and start with the demos, and at the end, just to give you an example of what we're going to be receiving, this is the type of metrics that we're going to get. So this is going to be the true positive rate, the false positive rate, the false alarm rate, the true negative rate, the true predictive values. So all this, the report will contain all those metrics that are listed here, and the report is going to look differently because it's going to be more compact. You're only going to get the abbreviations, not the actual name. That's why I'm mentioning first the names. But we're going to get, by running these few lines of command with a 5-minute video, you're gonna get all these reports. Now, starting from the terminal with the Virtual Studio Code, you need to click on this button here. That's going to open the terminal, and we start with the first command, which is basically going to the document folder, and the second command is opening the SACRO ML code, SACRO ML folder, which was downloaded in the previous version of the video, and then we're gonna activate the code. So this is when we activate the code. The third function, so now you have an option. If you use a Windows machine, you use that one. If you use Mac, you would use this one. But here we would start looking at the examples, and this might take a few moments for you, or it might be instant, but now we're in the example folder. So what does it mean? This command is that you're in the documents. In the documents you have the SACRO ML. Maybe you're gonna store yours in a completely different folder, not in the documents, and you might name your SACRO ML differently, but when you clone it, it's gonna be SACRO ML, depends where you save it. And within the SACRO ML, you're gonna have a folder called examples. Within the examples, you're gonna have a folder called sklearn, and within that, you're gonna have a cancer folder. So we're working with trusted research environments where we're investigating various different types of data. This is a data file from cancer patients. And the next command that you're gonna run is to train the model to attack this data file to see the performance. So again, we have a Windows command and we have a Mac command. So the difference here is that for Mac is Python 3, for Windows is just Python. And when we run this, now it's going to take a few seconds. As you can see, it's loading the data sets. It's splitting the data into training and test data. So that was the loading stage. This stage is also defining the model, training the model, and wrapping the model and the data into a target object. So that is basically what happened when we run this command. Now, before we run the next command, just to mention that next command might not work. If it doesn't work, you need to run pip3 install. So this is the command that you need to run. Pip3 is for Windows, for Mac. Pip without the 3, just pip install sklearn is going to be for a Windows device. Now, because we have already run that function, we installed the sklearn, we're going to go straight into the attack. And now when I type this command, and this is all open source. The files are available. You can clone the repositories, you can install them. When I click enter and run this command, you're gonna see many changes. You're gonna see how many models are being trained and how many of those models are affected, and then we're gonna produce the results. So let me click enter. And now it's thinking. As you can see, it's running the likelihood attack at this present moment from 0 models, then it's moving to 20, 40, 50, 60 models. Let's look at this code just for 1 second, what just happened over here. So you can see all these different models that they have run. It started from 0 models, ended up with 90 models. So this is training shadow models for the attack, and specific for the likelihood attack, which is also known as Lyra attack, but depends what abbreviation you use. Then we move into the second attack. So for the second attack, which is the worst case attack, so for the worst case attack, we're running the main attack repetitions, and then again it's creating the data, and then it splits the repositories. As you can see in this section of the code is explaining how it's splitting the repositories of the data, and then it's finishing with a simulated attack and running dummy attacks, and then sorting probabilities to leave highest value in the first column. So that is what the code is doing, and then it's creating the data, and it's again splitting it, and then it's finished simulating the attacks. So this is basically what the code does. Now let's see what is the next step for us from this code. Now we have an option that we can open to see the results. For Windows, this is the command that if you're doing it for Windows, and this is the command that we're going to use for a Windows device. If we're going to move to CD cancer, and from this stage you need to open the folder just to see what's in it, and for Windows that's dir, for Mac it's ls command. So we type ls command, and as we can see that there are 2 reports over here. Let me highlight them with an arrow. Those reports are in JSON and in a PDF format. Now to open those reports and to see them, you just need to open, and you need to identify the file and just open the file. This is the SACRO ML file. You're gonna find the reports under cancer. So first you're gonna go to skitlearn, which is under examples. So you click on examples. So let's repeat this from the beginning. So when you open the SACRO ML folder, you're gonna get those folders. And in the previous video we talked about the virtual environment and various other things, but here we're looking at the examples. And in examples we're looking at skitlearn, and in skitlearn we're looking at the cancer, because that's the data set that we use. And you can get this report in a JSON format. So this is the JSON format of the report. If you need a machine readable format, because the PDF file is not machine readable, and you can see what kind of attacks, so the Lyra attacks are happening. You can look at the code of how those attacks are designed, and here you have the true positive rates, false positive rates. Those are the reports. If you remember at the beginning I showed you this video with those true positive rates and false positive rates. So this is in the JSON format how those assessments are done. But you can also open this different folder, which is more of a human readable. It's a PDF format. So here we are looking at the likelihood ratio attack report, and all the different outputs like false and significance, those will be presented here. Now I'm just gonna spend a few seconds to talk about the metrics, and I'm gonna go through the first few because it's gonna be way too many to discuss all of them. For example, F1 score is here as well, but let's look at the first few. What do they mean? They are the same that we listed here in this folder. So the first one is TPR, stands for true positive rate, and this is the proportion of training in sample records that correctly classified as such. So the high TPR, high true positive rates, means that the attacker can recover real training data well, and this is the score that we have over here. The next one is the false positive rate, or the FPR, which stands for the proportion of testing out of sample records that they're incorrectly classified as training data, and high false positive rate increases the risk of false accusations. So this is the false positive rate that we have over here. Let's look at just the third one and the last one. the false alarm rate, which is FIR, similar to the FPR, but used more generally in attack detection context. Now, it's very easy to get access to this folder. I'm going to try to share some of this in the form of a Word document. But those are the very much traditional assessment scores, including the F1 score, which is harmonic mean of precision PPV, and recall TPR, balances both false positives and false negatives. And what is TPR? We go to the beginning, true positive rate. What is PPV? It's predictive positive predictive rate. So those abbreviations are all included in the Word file. Let's see what else is in the report. You're going to get a curve, ROC curve. What is ROC? Is going to be somewhere here in this list of definitions that we have. And it's the false positive rate and the true positive rate. So here they are all put into a diagram. We also have the worst case attack result report, which again follows very much similar pattern and similar descriptions, that what is the mean, what is the var, what is the minimum and the maximum. And this is the reports that you get by simply running these few lines of code. So far, to get this result, we actually had to open and to activate the repository, and we had to run 4 or 5 lines of code. If this doesn't work, it's probably because you have either you're typing Mac command into Windows on VS Code. Basically, that's the Python. Even if you go to the terminal, it's going to be the same. They have different commands for Windows and for Mac. Another reason why this might not work is if your institution has restrictions and you cannot install some of those packages like skitlearn. And if you cannot do that, then obviously it's not going to run. But as you can see, there's very few lines that you need to perform in order to get this report. Now I'm going to end it here, and in the next video we're going to be talking about a different topic. So in the next video we're going to be talking about how to create SBOMs, software bills of materials, and we're going to be looking at SPDX, Cyclone DX, and various different formats. And in the fourth video we're going to analyze those SBOMs with the common vulnerability scoring system, and we're going to position them in CVEs and NVD's National Vulnerability Database. But this is a good place to end this video, otherwise it's going to get too long and people just won't watch it. I hope to see you in the third video. And if you didn't understand the first part, please go back and watch the very first video. See you in the next one.